So just a reminder, if you look down below the video and in the description, we've got links to our Slack channel and the YouTube video channel and the index that I've created, separate HTML index I've created for the videos. And there's also a link back to the original ROS Agriculture videos. So that's just so when you dig through the stuff, you can go find it down there. And I think that's all I had to say. So I'm going to turn it over to Terry now.
Okay. I guess the first thing related to robotics is that I mentioned a couple of weeks ago that I'm mentoring a middle school robotics team with 5 6th grade girls, a 6th grade boy, and a 9th grade boy. We had our second tournament on Sunday. We ranked 5th out of 26 teams, but because 2 of those were already going to state, we're now going to state. So the youngest team in Minnesota is going to be going to the First Robotics First Tech Challenge state tournament. Woohoo! So I'm pretty proud of them there. I've been continuing to work on my autonomous snowblower, or snow thrower, I guess is the proper term. But I had 2 different friends send me links. One was to a autonomous snow blower company called Yarbo that has a really neat snow blower. It's a bigger one. I mean, it's not just a teeny one. It's, I think, 32 inches wide. It's a tracked vehicle, but they created it in a way where it's modular. So there's kind of the robot base unit that has all the controls. And then let's see if I can figure out how to share this. There. This is the YouTube of the unit. But the blower is a separate unit from the robot itself. And the robot itself has the GPS and all of the control mechanisms. This has a bumper. It's got a forward-looking video camera that will stop it if it sees anything move in 15 feet within 15 feet in front of it. It can blow snow. It says 40 inches. And the videos are pretty impressive. The other thing I wanted to show, though, was someone has made a 3D printed snow blower for RC cars or trucks. And so this is this one. And again, it's a separate unit, but it is all 3D printed with a few minor exceptions for like there's a couple of bearings and obviously metal screws. And then one of the gears is, or a couple of the gears are metal. But I like the idea of that first one where it's modular. So I'm thinking that I'm going to make my snowblower an attachment to a base unit so that if I want to put a brush on, a rotating brush for if it's a real light dusting of snow, or if I want to just clean the driveway. Let's see what else. Okay, now I'm going to move this over here. And now I'm going to share a different screen. I've been doing, I'm wanting to 3D print this. And so I'm trying to get this all put into Onshape. And then because it's 3D printed, I have to make sure that I can fit the pieces into my 3D printer. And since I can only go 5.5 inches tall, I have to make sure that no piece is bigger than 5.5 inches tall. So that's why there's 3 across. But next piece is going to be the, I've started working on the skid plate for the bottom. I've already got the blue scraper plate, which will be a piece of aluminum 1/8 inch thick. But now I'm going to put on the skid plates and then get into the power drive unit that'll be an attachment here. But it's been keeping me busy along with the robot team, getting them ready for state in less than a month. And that's all I have.
On that snowblower thing right there, have you decided how fast you're gonna have to spin that? Which will affect what you pick for motor and your say chain or belt drive to it.
Well, I think I'm going to go with a belt drive. And I'm wanting to get a RPM, I think about 500 RPM. And so I'm going to use a 1-to-1 gear drive, but the motor that I'm looking at has a very configurable planetary drive system where it comes with a 5-to-1, 4-to-1, and a 3-to-1 that can be stacked in any configuration you want, so that I can vary my RPM once I actually see what the snow's like. And I do plan on having it be 2-speed, based on the quantity of snow. Does that answer your question, Jeff?
It does. I just know that if you've got a big snowblower, if you've got the 2-stage one, it's got like a spiral auger in the front that breaks up the snow and moves it to the middle, and that turns fairly slow, and that's got the big high speed impeller in the back. And then when you go to the single stage ones, they basically just spin that fast, and that actually it breaks up the snow and moves it and throws it all out at the same time. So the little ones like that typically run faster, and I have no idea how fast is fast, but
Right. And that's why they
just
also
something to think
have
about.
this so that it throws it from the center.
Uh-huh.
So it gathers it and collects it and then throws it through the center. But it'll be an experiment. This one, the 3D printed one, has a 10-to-1 impeller to auger ratio. So the impeller that actually throws the snow, the second stage, goes 10 times faster than the auger that breaks it up.
But on what you're doing or something else you're looking at?
No, that was that orange 3D printed RC
Oh, okay.
snowblower. And it happens to be that the guy sells it, but I don't know that I want to spend $750 for that kit. But he is from Minnesota, so he should have the snow to know what he knows what he is doing. And it looks like it's pretty impressive. And you can buy the step files for $40, which I might actually do.
Once you have those,
But
can you scale it up and down?
probably to some extent. I think his printer is larger than mine. I'm going to use it more for ideas and thicknesses and, for example, like ways that he interconnected his back panel. That's where I got this idea.
The RC snowblower that you found, did they talk at all about what truck they used? I'm just curious what sort of platform they built that on.
He's actually got a couple that he works with. One is a snowcat, which was not in this picture, which is a tracked vehicle. And then this is he does list them. If you go to his YouTube channel is Spyker Workshop.
That'll be fun to look up.
And then he's got links then to his website where he's got great instruction videos on assembling the snowblower and the mount to, I think he's got 3 different mounts that he has.
And the First Robotics, what's the physical challenge that the robot is judged on?
There are a couple of them. The overall theme is the deep, and the idea is that you're part of a deep submersible exploring the ocean floor, and you want to collect samples and specimens and put them in various places. You can there's a human element that can attach a clip to a sample, making it a specimen, and then you can put it on either a low bar that's like at 15 inches or a high bar that is at 30 inches. If you put it on the 30-inch bar, you get 10 points for each one you put on. You get, I think, 5 points if you get it on the middle bar. And then during the end game, you want to try and hang on the submersible so that you're completely off the ground.
If you think about it, it would be fun to see normally somebody videotapes those things. It would be fun to see the videotape of the thing running around doing its thing.
They actually did videotape the entire tournament last Sunday. And I can send that link to Jeff along with time spots when my team was there.
That'd be cool.
But yeah, each match has 4 teams in it. There's a blue alliance of 2 teams and a red alliance of 2 teams. So you have to cooperate and figure out a strategy on what your robot does better than your alliance partner's robot and figure out how you want to get the most points.
The other thing I was just going to mention quickly is I don't know if you've ever looked at Bob introduced me to something called Miro Board, M-I-R, I think it's just one R, M-I-R-O-R board. And I found that to be really useful to lay out sort of the project and details, and it's sort of the go-to place for reference material for me. And because I was ending up with Word documents and all kinds of stuff. I don't know if if you figured out a way to store all your
not really for my project, but I did make a note of your Miro, and I plan on looking into that. I thought I was going to be kind of done with robots this week, but then they decided to win state or go to state. So I'm
tough problem there.
4 hours tonight, tomorrow, and Sunday, which doesn't leave a lot of time for other things.
Yeah, I know. I was just going to mention it.
That's kind of where I've been.
So Al, do you want me to go next?
Yes, please, and I'll go on mute.
Okay, if Terry would stop sharing the screen, we can move on here.
I'm sorry.
I might be able to turn that off. I've never tried. So anyway, the last couple of meetings we were talking about powering a Raspberry Pi, and I said that when I ordered this cable. This is something that Bob found on Amazon, where it's just a cable. It just has bare wires on the other end of it, and it's supposed to be rated at 5 amps. So I ordered that cable. When I was doing it, it says, "Oh, here, you might want this board too," and it's just a little, like a $10 board from Drok, Drok, yeah. And it says it'll take like 6 to 32 volts in, and then it's got 5 volts out, and the output, it's got screw terminals in parallel with the USB connector. And theoretically on there, it's not documented very well, just like most stuff you buy these days. But down here at this end, there's this little tiny chip, and it's hooked up to that USB connector somehow, and they call that the Smart Charge ID chip or something. I have no idea what that does. So I just went ahead and hooked the wires up to the cable that goes right to the USB here. And Bob bought a different one, so it's from the same company, but it pretty much works the same way. But his has an LCD on it that shows you the current, and you can either select the input voltage or the output voltage. And I think that one goes for like $15. And this one I just bought it because it popped up and said, "Here, you might want one of these." So I went ahead and got one. So just to show that I did something, I put my input wires here. So these just plug onto my lead acid battery, and I put a fuse in between, and then that goes to the board here. And I put the ferrules on the stranded wire here to go into the screw terminals. And then likewise on this end, I've got just took the red and black wires there and put 18 gauge ferrules on those and plugged them in the screw terminals. And basically, and I can plug this right into the Raspberry Pi 4 and power it up, and it runs just like it's supposed to. I only ran it for a few seconds because the battery I'm using is almost ready to die. So I powered it up, and it did boot up, and that was working. So then, as I was playing with this stuff, I was noticing the screw terminals and all this stuff. So, for instance, the screw terminals on this board are the type that's got it's got like just a little bent over metal tab inside. Like I don't know if this is going to work. So on this one, this is the one with the metal tabs. And right now, when it came, they were cranked down all the way, and I backed off the let's see which ones here. So these first two here, I backed those off all the way, and see that metal tab doesn't come back up. So what you got to do to make those work, because that's not big enough to put your wire in there. So take something here. This happened to be half of a cuticle scissors that were laying around, but it's nice and stiff. And I can just put that in there, and you have to put it in there, and you have to bend the thing up, bend that tab up. It's not going to show up, is it? Should have done this ahead of time. Or you can get something bigger. This is the nail that was laying around on my floor, so I can cram that in there. That's not going to work either. But the point is, like on this board here, when I went to do this board, I couldn't get the ferrules to go in, and the ones on the power end, maybe it's because I had stiffer wires, I was able to wiggle those and get those again. These didn't want to go in. And actually, here's something else odd that happened. The plastic part of it slid, so it's not where it's supposed to be anymore. But anyway, I went to put those in. I couldn't get them in the hole, so I took. Then I found that nail laying around, so I shoved that in there and wiggled that to open the thing up. And I was able to put my things in or screw them down. And it turns out you can get the ones. So again, these have the little just flexible, bendable tabs here. I really want that to move. Let me see if I can get something to go in there. This isn't doing what I think it is. Huh. Well, I guess that one's not going to work. And then you got the other type, like this actually has a turn off my background. Come on. So this one has little metal blocks in there, and as you run the thing, maybe I can show this here. So if you watch inside of there as I turn this, you can see the blocks coming up from the bottom as I turn this. So it actually grabs the wire between the top and that block. And these, when I back off, then it goes back down like it's supposed to. So if you got this kind, these work out fairly well. But if you're buying something on Amazon, you don't really have a choice of what you're getting. But anyway, those work. And this happens to be 14 gauge wire with a 14 gauge ferrule. And those do pop right in there. And then if I screw it down, that gives you a nice tight connection on that. So what was there? I think I was going to show here. Then of course you can get ones that just have, actual, physical screws. It's just a smaller version of the big ones that you normally see. And those are just little spade connectors. They're pushed on there and then tightened down. So that's a different type of screw terminal you can get. But anyway, I started thinking about screw terminals because I couldn't make it work. And then I found out if I shoved a nail in and opened the connector up and then put my wires in. So I got past that problem. And maybe that's all I had to say about screw terminals. But again, when you go to do this, and the other thing is you might be able to use a drill bit. I think this is I think it's a 16th inch drill bit, or you could use like a small Allen wrench, because what you want is you want this part, you want to be able to shove that in the terminal and pry it open when it's got those ones that just smash down the piece of metal. So you need to open those back up in order to do anything. And I still can't figure out this one I've got here. I don't know why I can't get that open to put the wire in. So anyway, back this way, it's on a little relay board. And I was prying on those. They don't want to move, even though I backed the screws off. So, just a relay board looks like that. So I've used these before. So I know these terminals work on a different board. So I don't know what's up with that. So anyway, that pretty well sums that up, the fact that I just hooked up that board, and yes, it does give me 5 volts. I will power up my Pi 4. I could plug this directly into a Pi 5, but on that one, it's got some new magical stuff built into it that goes out and it interrogates your power supply and say, are you a 5 amp power supply? And if nobody answers back, like in my case, it won't answer back because I don't have an official power supply. So you have to go, and it looks like there's 2 different ways. Maybe you can do either. Maybe you have to do both. But there's a configuration file somewhere. You have to go in. You have to type in USB max power enable equals 1, and then apparently it'll say, oh well, he wants to run this even though he doesn't have a 5 amp power supply. So that might fix all the problems. And somebody else says, well, you can go into the EEPROM, which was new to me. It's something to do with booting or something. They say you can go in there. You can put a parameter that says something like power supply equals 5,000 milliamps or something like that. And so possibly one or the other of those, or maybe you have to do them both. But when somebody gets around to trying their Pi 5, we can find out on that, what you have to do to make that work. So, but theoretically, what I have here, this should plug right into a Pi 5 and power it up. It's just that if you want the problem is if it doesn't see a 5 amp power supply, it says I'm going to limit your USB ports to 0.6 amps as opposed to 1.6 amps. And that can be a problem depending on what you're trying to drive. And the other problem is if you're trying to boot from a USB, it'll say, oh no, I'm going to refuse to boot because you don't have a 5 amp power supply. So I think if you just type in that configuration thing, that'll get around both of those problems and everybody should be happy at that point. So we'll find out when Al gets around to trying his. Bob's got something set up. I was going to show, let's see how long it would take me to find Bob's stuff here. Let's see. Go to the screen. Go to here. That's probably random. Get those crap out of the way. But he took a picture of what he had set up, and okay, I thought he had 2 pictures. Well, here I'll do it this way. I'll say share screen, and we'll go to this screen. Make this bigger. He's out of my way. So this is the one that he ordered from Amazon. It's also a how do I do this? It's also from Drok. Come on. And see, it's $15 for this one, and I think it basically has the same specs as far as 6 to 32 volts in. and it says it will do 5 amps. You got to be careful because these things always say it'll do 5 amps, but if you're going to use more than X number of watts, you got to put a fan on it. So that's something else to keep in mind. And it just basically looks like this. It comes with 2 plastic plates. You can stack this stuff up, and it's got screw terminals on the input, and then on the output it might have oh 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 this is just an image. I can't click on the other things here. And he didn't post a link to this. You just have to, if you want to know it, you have to type in I think I put in Drok DC buck module. But just that will probably get you there. Then go to Amazon and search, and they've got several that'll show up, and this is one of them that's there. So anyway, this is what he bought. And if you look at the display, the bottom numbers here are current, and the top numbers of voltage. And somewhere it says, I think these red things are push buttons over here. And I think you push a button, it'll switch that from, you can either see the voltage on the input or the voltage on the output. And then this is probably like a battery indicator of how much capacity you have left. And these screw terminals down here are these pots. One of them adjusts the output voltage. And I think the other one might be like a current limit, because they say there's going to be a battery charger or something. So they got some features in there. I think it's one of the pots, I think is some like maybe current limit or something is what that's for. So let's go back to here. So here is a picture of Bob's setup that he was playing with. How come nothing's working here? Well, it's not going to let me zoom in. Oh, well. So anyway, here's his, down on the bottom, he's got, this right here is a battery he's got down here. And I don't know if it's lead acid or what it is, but he's got this red switch on one side and a red switch on the other side. So this switch controls his stuff over here. It's his some kind of a VEX controller. And the one on this side, this red switch comes up to these wires up to his power supply. And then coming out this side is that USB cable, like I just showed, that this is the one he found. So here's his red and black wire. Why can't I zoom in? I can probably do this. Let's try that. There we go. So I can't see where I'm at. So again, this is his battery, and like a couple photos back, he showed this. I think he's got a couple batteries hooked together, and he's got thermal strip on the top, and he's got 2 lighted switches on the front. And he said the one on the one side runs his Raspberry Pi, and the one on the left side runs this stuff, which is turned off right now. So let's see now. Okay, so there's his power supply, and it's putting out 5.03 volts. Mine, by the way, is putting out 5.1 volts. Just taking it out of the box and turning it on. That's what it did. But there's no adjustments on mine either. And it's drawing 0.75 amps. And see, here's his USB cable. He just got hooked up to the 2 output terminals. And then this is his Raspberry Pi back here. You can't really see it, but here's the USB-C connector plugged in the side of it. And when he's running this test, he didn't have an operating system. He was just powering up the board just to see if it would work, I guess. And he says under those conditions, it's taking 0.75 amps, just sitting there doing nothing. So that's what Bob is doing. That was going to be his approach. So he's going to have the same problem. Once he gets the board powered up, he has to go in and change that configuration and lie to it and say it's a 5 amp power supply to keep everybody happy. So let's see, I think I'm done with that. I talked about the screw terminals. Okay, let's, how do we stop sharing? Aha, okay, so I'm done with that. So let's see, I said I got the power supply working. I talked about screw terminals. Oh, and on the wires, I did put on the crimp on ferrules, where it's got, you take your stranded wire, you get this whole box of little crimps, and you pick the one you want, you slide it on there, and then they give you a crimper with that. So you just put it in and it smashes the thing onto there. So now it's just a solid, it gives you a solid metal thing instead of your stranded wire that goes into the connector. So you can clamp down on that on your screw terminal and make that work. And I posted a link to a video from 6 years ago when I was talking about buying these and using them. And maybe it wasn't that far back. Anyway, I can repost that. I'll put that in the description so you can go back and watch that video where I'm talking about that.
Have you found those ferrules pretty reliable?
So far, I thought I broke one of them. So when I was just doing this board here, I crimped them on. I was trying to shove it in the thing, and I felt it kind of go thump, and it went in, so it did what it's supposed to. And then for some reason I took it back out, and the metal part was too short. It's supposed to be like that, and then see, like down here's the plastic part, and the pin's sticking out. When I pulled it out to look at it, I saw that much. I thought, oh, I must have broke it off, must have snapped it off. Well, it turns out what happened, the plastic thing had just come loose and slid up on it. So that was, so far, that's the only failure I've had, is the plastic thing. If you push on it too hard, it comes loose, and it will confuse you immediately if that happens. So, but other than that, I haven't had any problems with them, but I don't really use them a lot. Here's another one where this is one of those. There's one of those motor drivers like Al just said he got, and this has the I think this is 14 gauge wire with a 14 gauge. No, this isn't 14 gauge, because the black one is the black wire here. That's, oh, I guess they are. So the color of the ferrule, the color of the plastic tells you what size it is. So the blue is 14 gauge and the red is 18 gauge, and they give you like 6 different sizes in the kits that you buy. And why was I talking about this? So these big wires, they go into these nice, this is the connector that had the little thing that slides up and down, as opposed to just smashing them. And it seems to work out on those. So, but
Okay.
yeah,
Thank you.
they seem to work, and they're real handy. And as I say, I'll post that thing. You can back watch my other video when I was talking about that. So the next thing I did, I was playing with flashcards and learned a lot about flashcards. And the first thing I did was I just went to, I fired up RPi Imager and went out to the, I ran that, and it says, what operating system do you want? And I went down where it says other, and I said Ubuntu, and I said I wanted Ubuntu 2404 desktop, 64-bit. I clicked that, and then I clicked on what flash card I wanted, and I put a 16 gigabyte card into my reader and said go, and it actually created the card. I was able to put that in the Raspberry Pi and boot it up, and everybody was happy. And then after that, I haven't had good luck after that, but so I played with the Raspberry Pi Imager, and that'll let you do various things. If you go all the way to the bottom on that, one of the options says you want to erase a card. So you can click on that, and it says it'll erase the card and reformat it to, I think, FAT32 or whatever it is. So that's a handy tool to have. And then also in that one, it says, do you want to just flash an image that's already on your computer? So at one point, I took my card that I'm running right now, and I used DD, which is the Linux command, and I copied that card onto my hard drive as an image. But it turns out the Raspberry Pi Imager will not, it doesn't like that. It says, oh, that's an invalid file or something. So anyway, that didn't work. So I went back and used DD to write it out. And then the other problem I ran into, the fact that these cards, it turns out they're different sizes. I don't think any 2 cards is the same size. And it has to do, when they get the card all built, they go test it, and if it's got 20 bad sectors or 100 bad sectors, I think they just knock those out somehow, and then they still tell you it's still a 16 gigabyte card. And the one I started with was 15.8 gigabytes. And then when I was writing it out, I was trying to write it on a card that said 15.5 gigabytes. And it turns out that if you put that into the RPi Imager, it'll say, oh, you need a card of at least 5.8 gigabytes. And so before it does anything, it tells you that. And in fact, that's the one where I was trying to write out that image that I'd created. And that's the first thing it told me, I've got the wrong size. So I found a different card and plugged in. I think I went to a 32 gigabyte card and ran it. And that's when it came up and says, oh, that's an invalid image. You can't write that out. So that was kind of a waste there. But so then I went in and used DD to write them out. And I found out that as long as you're writing to a bigger card than what you started with, DD seems to work just fine. But if you're trying to write it out as like 1 byte too small, RPi Imager will complain and tell you it's the wrong size, and DD will just sit there for 15 minutes. And when it's all done, it says, oh, well, by the way, you wrote past the end of your card, so you're screwed. So you just wasted all that time, and it didn't bother to tell you that. So that's just more things I'm learning. And the best way is, if I've got a 16 gigabyte image, if I put in a 32 gigabyte card and write to that, what it does, it fills up half the card. And then as soon as you plug it in the computer, as it boots up, it says, oh, well, you got extra room. Well, whether you want me to or not, I'm going to expand that to take up the rest of the room. So it automatically does that for you when you do that. And then somewhere along the line, I was having problems with my cards, that all these old cards kicking around. Some of them I wrote hosed on top of it because it somehow it screwed up the directory or something. And I can't figure out how to recover those cards. And then other cards, you know, they just have stuff written on. If I put those in, there's a good chance I can write to those. And then Al was saying he's got those 64 gigabyte cards that he bought, and they're an actual brand name as opposed to these ones that Micro Center sweeps up off the floor. And that's why I have such a wild problem with the different sizes. Now I need to go through I bought 5 of those new ones. I need to put them in one at a time and verify, you know, what the size is. I don't know if those are all going to come out exactly the same size, being a name brand card, or if I'm going to have the same problem with those. And the other option is, I have 2 more options, and I'll link the video to that too, where I was talking about trying to burn, trying to do this exact thing. This is the one that was 6 years old. And that one I was saying, if you use the imager from Windows, I think it's called Win32 Disk Imager or something like that. And on that video, I said, there's a checkbox on the screen. It says something about don't read unallocated space or something like that. And at the time I made the comment, if you set that checkbox, it actually creates a smaller file. So it could be if I'd run that program against my 15.8 gigabyte card that's too big and load that into an image, it could be able to create an image that's going to be around 13 gigabytes, which is what that card has on it for space. And then I can write to any of my 16 gigabyte cards. So I'll put a link to that one too if anybody wants to go watch that. So let's see. I wrote to the 64 gigabyte card. I took it right out of the package, stuck it in, so write the 16 gigabyte image to it, and it had no problems. It didn't complain. I pulled it out, stuck it in my Raspberry Pi, it booted up, and everybody was happy. And that's where I was specifically checking. So before I did anything, I took it brand new out of the box and ran various Linux tools to find out the sizes, the number of sectors and all this kind of stuff. And then I used DD to write to it, and then used, it's called disks, BISKS, under Linux, where it shows you a picture of the, shows you a picture of the partitions and everything. And there I could see that it wrote at a 16 gigabyte Linux image, and it said 16, or on that card it said 47 gigabytes of unallocated space. So then I plugged in the Raspberry Pi, booted it up, and then went back and looked at that. And now it says I've got like a 62 gigabyte Linux partition. So it just automatically expanded out for me. So far I've had no problems with those cards, and I've still got everything else is the cheap ones that I buy up at the counter at Micro Center. And I'm not sure if it's because of the card itself or the things I've done to them over the years. So anyway, I kept fighting with flashcards, and that's kind of where I'm at right now. Oh, the other problem was I started with a 16 gigabyte card, and I loaded Ubuntu 24.04, and I loaded ROS Jazzy, and then I loaded that micro-ros that Al's been playing with. And then I decided to back it up. And I noticed while I was doing that, I've now taken 13 gigabytes of my 16 gigabyte card, and the 16 gigabyte card is really only 15.8 gigabytes. So I decided I would write that out to a 32 gigabyte card. I've got one 32 gigabyte that actually works. So I copied everything on that. So that's my working disk now. I'll work on that one at 32 gigabytes. It'll take me a while to fill that one up. And if I need to, then I can back it up and copy that to the 64 gigabyte ones. And as long as I know what I'm doing there, that should all work. So I think I'm down to the point where once I blow it away, I should be able to recover fairly quickly. So that's
another thing I remember reading was for the Raspberry Pi, you want to use one that has a sufficient speed for those cards, because since it's being used as the page file is on there, you need to have fast read and write. And sometimes those generic cards aren't fast enough.
Well, the other odd thing is you look at the card, and it's got like 10 different little stamps on there. It says class 10, it says it's UHX or something. They got a whole bunch of things on there, but I think you know, I was going by that class 10. They say on a Raspberry Pi, make sure you get a class 10 card, and the ones the cheaper ones from Micro Center are marked that way. And they, you know, in general, I run them and I don't seem to have any problems with them.
Okay.
So another thing that came up since I was burning flashcards, I thought, well, let me load up the actual Raspberry Pi OS onto a card and put that onto my Raspberry Pi 4. So I did that, and I don't remember what I was doing. I probably had some other stuff running on it. I thought, well, I want to open a browser, so I opened the Firefox browser, and it seemed to take like 5 minutes for it to even pop up on the screen. And then it showed me like 2 tabs at the top that were already, it says, oh, here's the Raspberry Pi documentation page that they somehow pre-programmed in there. And I clicked on that, and that took, you know, like a minute to bring up the page. And then I clicked on a tab there, and again, it took like 2 minutes to do anything. And I finally got that, I'm tired of this, that crap's not going to work. And then I shut that down. I started Chromium, which they also pre-installed, and it was acting really stupid too. So for some reason, neither browser works with the official Raspberry Pi operating system on a Pi 4, and I don't know why. It could be that I had other stuff running and took up all the RAM or something, and it could be that you have to run it once and then shut it down and start it again, so it cleans everything up. So I'd go back and try that again to see what it does. But anyway, I wasn't at all happy with the official stuff because it would not run. So that's one of the things. Oh, because I was going to try to do that because Raspberry Pi, the official image it says clone a flash drive or copy a flash drive. So I was trying to get 2 flash drives plugged into my USB ports on my Pi and then run that software. And then at that point, it kept complaining my output card. It didn't like it because whatever the reasons were. And that's just more that I think I solved those problems by knowing don't use those cards or whatever. But anyway, that's why I fired it up. And I thought, well, that seems like a lot of work to do that, but it might work. And I think I would have had the same problems. It would have said, oh, it's not going to fit on that card because it's going to check for the sizes and so forth. So that was, I did a lot of fighting with that stuff. And I finally got my Pi 4 to the point where it's running. I can power it up and run Ubuntu and Jazzy. And so then I moved on because one of the reasons I was loading this up, because Al was saying he's trying to get micro-ros to run, and he loaded it, and then it seemed to blow everything away. When he gets on, he can explain all that, but it looked to me like, from what I heard him saying, I thought he had a working system. He ran through the steps to put this micro-ros on, and then it wouldn't work at all after that. So I was trying to think what would cause that, and without having something in front of me, I could only guess. So I went to the page and started doing that. So what I did first was I fired up my system and then ran the talker listener demo to verify that that's talking. That verifies that Jazzy is running. And I shut that down and did the first step. There's a box on there, like, you know, it's got like 10 statements in they want you to type in. So every time I do a statement, I'd run that, and then I'd verify again the talker listener. I did that on every one. I figured if it does die, I would at least know at what step it made it do that. So I went through all those, and that seemed to be happy. And then I went on down below. There's something else. Is now you have to build the micro-ros agent. So you download some other stuff, and it compiles some stuff. And then at the very end, it says, here, type in this line. If you're getting this output, it's working. And what it is, it's an output from micro-ros agent saying, I can't find the serial port. And apparently, so if it's getting that far, they're assuming that your software is running well enough that it's trying to contact the serial port. And the next step I was supposed to do was get a Teensy or whatever Arduino you want and load. They wanted me to download stuff and compile it and put it on that card. And then theoretically you plug it in, then that little demo thing on the, and in this case, a Teensy 3.2, it's just putting out an incrementing number. And then that should go back to ROS, and you can do a ROS topic list and see the topic that it is, and do a ROS topic echo, and then see the actual numbers the thing's sending out. But I just got to the point where I got the ROS side of it installed, and everything still worked when I was done. It didn't crash. And so that would be the next step. If I want to run micro-ros, I'm going to have to get something for it to talk to. And I think that pretty much is all I've done this week. It's just been fighting with stuff, and but I've got to the point where it's, some stuff's running and I'm happier right now. I'm to the point where I decide I need to have 32 gigabytes minimum. So I've got that copied over, and that's the card I've got. So I can run from that and everything. Should be happy for a while. So we'll see what Al has to say. Maybe give us some comments on why his ROS install died when he's trying to install micro-ros.
Yeah, I mean, getting a Teensy to be able to subscribe and publish, this is what I think I know. There's two halves to the process. One is to get on your host, ROS2 Jazzy and that micro-ros agent installed. That, for me, has been simple and without issue. I followed that automatic Addison steps, and those worked fine. Now, he had some steps in his to also install Gazebo, and I think there's some version issues with the Gazebo thing, but that doesn't have anything to do with the micro-ros. But anyway, those instructions have worked perfectly fine for me. It's getting the micro-ros Arduino library downloaded, installed, and working that's been problematic for me. And I had a little bit of success that I posted. Actually, you might not have noticed it, Jeff, because I think I replied to an earlier post, so it's sort of embedded in a reply. So there's a post where I mentioned getting the automatic Addison demo publisher subscriber working, and then I subsequently replied to that with some more challenges, and then ultimately a little bit of success. So I believe the problem is getting the Arduino micro-ros library installed is finicky. And by finicky, I mean I couldn't get it to work with Arduino 1.8.19. I couldn't get it to work on using Platform IO on the Raspberry Pi 5. I couldn't get the C compiler using a make statement and trying to remember how to create a make file on the Raspberry Pi 5. Again, all of this is focused on the micro-ros Arduino library, getting a clean compile on the Teensy using the publisher. What I was able to get a clean compile on was going to my Windows 10 machine, putting Platform IO on there, and using Platform IO to compile the publisher example on to the Teensy. I could not get Arduino 2.3.4 or whatever. Couldn't get the pre-compiled Arduino library. I ultimately had to create, in addition to the source library for my project, I had to add a lib folder, put the library in the lib folder, compile it all together, and my only claim to success at the moment is I've got a clean compile. And in my programming days that I got a clean compile, I was 95% there, which we all know is completely false. So anyway, now I have to test the actual publisher on the Arduino, on the Teensy, using the micro Arduino library and being able to see that on the Raspberry Pi 5. So a little bit of progress, but a lot of frustrating things that didn't work. And on that SD card thing, I had some issues with my SD cards too, and I thought that they were good SD cards. And the only thing that seemed to make it a little bit better is if I formatted them completely before trying to use the Raspberry Pi imager. That gave me a little bit better performance than if I tried to use the RPi imager on top of a card that had been previously imaged.
Another thing I ran into is looking at different descriptions. Sometimes they say you have to unmount the SD flash card. Sometimes you don't unmount the card. And when I was running DD, I would just say, put the card in, run DD. Well, I think it was mounted. I could say, read it and create an image, put another card in, and don't unmount it and just write to it with DD. And that seems to work. And I'm not sure. So that's all confusing too, to know how that's supposed to work. So yeah, I just say there's lots of confusing things around trying to figure this stuff out. Well, back to the comment about trying to install micro-ros. Your comment says you weren't having any luck with it, and I wrote back, says, well, what's your problem? Says, well, I can't even get a simple publisher to work. And I thought you meant your talker listener demo had quit, and that was the whole reason I kept testing the talker listener demo while I was installing the stuff. But you apparently meant you can't get your Teensy 3.2 to publish anything in ROS, I guess is what you meant by that. So I was confused. I thought we lost Al for a moment there, but looks like he's still there.
Yeah, you did lose me, but I came back.
Okay. So I don't know if you heard that last thing I was saying, that I assumed your problem was when you installed the stuff under ROS that your talker listener no longer worked, but apparently it meant you just couldn't get the numbers from the Teensy 3.2 to publish into ROS when you said you couldn't get a simple publisher to work. So it's good to know that we both have that stuff installed and running, and so I guess somebody's got to figure out how to get the Teensy part of it to work.
Yeah, to try to be precise, I struggled just getting the daggone publisher example that would run on the Teensy to compile. So a mountain of work to try to just get it to do a clean compile. And that's all about finding the libraries, being able to do the links on the Teensy. So if you do that smooth sailing, boy, please write down what you did. Because I struggled mightily just to get a clean compile of the micro-ros Teensy example, publisher example.
Well, I had simply decided I wasn't in the mood to fight with that, so that's why I didn't do that. I thought I'd made great progress just getting the ROS site installed, because I thought that's where you're having problems. So I haven't gone and done the rest of that yet.
Good luck.
I was noticing somewhere that it's got a whole list of things that this might run on, and one of them was the ST32 stuff, STM32. And like the little boards like this, the little $3 boards that it's got, depending which one you buy, you can get one that has plenty of RAM and ROM on it. And so it might be worth trying to track that down. But I assume it's going to have to go to the ST micro development system to do that. So, but I probably won't get up the ambition to do that very soon. Another thing I thought of on when you're running ROS serial, you were starting up multiple ROS serial nodes and you had multiple Arduinos you're talking to. Have you noticed if this micro-ros is going to let you do that, or are you going to be better off just putting everything on one little computer and not having multiple computers?
I have no clue. I'm like just scratching the surface at the moment. And if I have much more trouble, I'm just going to say screw it and go back to serial communications, because I don't have that much data. What I'm trying to do is not that complex, but I would rather use micro-ros.
Yeah. And I suppose anything that's supposed to work with ROS2, it'd be good to, if somebody figures it out someday, but if it's going to be a pain in the ass and you can't figure it out, just move on to something else, and somebody will eventually figure out a workaround for it. As you say,
I think I'm good now. I've got a platform IO.ini file that's got the right flag set, and it's compiling. So I'm pretty confident that the hex code it generates is getting up to the Teensy, and it's all supposed to work. I'll know that as soon as I can have a little bit more energy to actually see, did it publish publish what it's supposed to publish.
Okay, that sounds good.
That's it for recording for me, I think.
That's probably it for me too. You got anything else, Terry?
Nope.
Okay, then I'll shut it off.
Actually, yes, I do.
Okay.
What would be because I debated about this a couple months ago about going with the micro-ros versus just direct RS232 from my Raspberry Pi to my my Itsy Bitsy, which I'm using for motor control and battery monitoring.
Well, there's actually several things you said there. You said either micro-ros, which probably would go over your USB cable, or you said RS232 serial, which I doubt if you're ever using RS232 serial. You might be using TTL serial between the boards.
Yeah. Okay. Yes.
Or
yes, you're right.
Or you could plug a USB cable between the two and still treat it as a serial. So what it really comes down to is that the micro-ros is just simply they designed that to work. You're supposed to just be able to drop it right into your ROS on one end and drop it right into your little board, whether it's an Arduino or whatever, on the other end. But as Al's pointing out, it depends how easy it is to get that to compile. But he also says, if you want, you can just drop back and just have open a connection between the two and just use print statements and send stuff back and forth, and that will work. That will work too. I was gonna say, unless you're sending a lot of data, or unless you're doing something really fancy, and I'm not sure if micro-ros does anything fancy. I've never used that before. This is the first time I did anything with it. I was trying to install that. So I guess the point is, if somebody gets micro-ros working and says, "Oh, it's great," just go with that. Then go ahead and go down that path and try to get it to work. Otherwise, you can just send, from the upper system. If you're trying to control motors, you'll send like a command velocity message down. So just make a print statement that says, "This is my command velocity, and here's my 2 or 3 values I want." And you just send that down the port. And then the bottom says, "Oh, I got this command," and you do what you want with it. So, and that's not that hard to do that. That's basically the way I do all my stuff.
That's
And
what
having
I.
spent a little bit of time,
Go ahead, Al.
a little bit of time with ROS serial and getting that to work in the old days on ROS1. I mean, the benefit was that you get the subscriber publisher standard sort of communication. Plus, if anybody else, you borrow somebody else's code and it's using that publisher subscriber metaphor, then it's going to work. Otherwise, you're dealing with a bespoke interface on whatever topology you choose, and it's bespoke. But it's a couple days ago, I was ready to throw out micro-ros and just go with serial communication. So we'll see.
Have you given any thought to try to get ROS serial to run under ROS2? I don't know if anybody's attempted that or not.
Oh no, I didn't. I didn't even Google search that.
So that maybe somebody has done that. I know the guy that wrote ROS serial kept saying, "God, I wish that would just die and go away," but people keep using it. And see, I don't use either ROS serial or micro-ros. I just simply just send whatever I want back and forth. So I just have to know if for my ROS node that I write, if I receive a message that says, "Here's wheel odometry data," I received several numbers. I just have to parse those out and build a message in my ROS node to say publish an odometry message. So it's maybe takes a few more steps and to do that, but it's also just pretty straightforward stuff. So you've got several options there.
So I'm anxious to see if you can get a clean compile and just use the micro-ros publisher example. And if you get a clean compile, I owe you a beer or whatever your favorite beverage is. man, I could not get it to compile.
And at this point, I don't know. I assume I'd use the Arduino IDE either on Linux or on Windows. And again, I hate to touch Windows. I'm trying to get rid of it, but if I go back and do that Win32 disk imager on Windows, I'm going to fire up my Windows computer again to do that. So, but anyway, that's what I'll do. I'll just try to take their example. I'll look at that. The example was that wasn't on Automatic Addison. I think that was on the actual ROS page, the stuff you were following. And I'll look at that first and try to do it like they say, if it fits in with what I have. So, well, I'll see if I get around to that and try it. Anything else? I'm assuming that's a
Not on
no.
my end.